Hi students, welcome to this session on Coulomb's law. In this class we see Coulomb's law statement, significance of Coulomb's law and the meaning of each terms in Coulomb's law. Let us start the discussion. Right, so Coulomb's law was proposed in the year 1786, that is 234 years ago. But still it is relevant. Many applications are developed using Coulomb's law. One of the main application is Xerox machine. How it is used in Xerox machine we will see after understanding Coulomb's law. Right, in this class we are going to see statement of Coulomb's law first and significance. Right, so before we learn Coulomb's law we must know what is electrostatics. Electrostatics is nothing but study of charge in rest or study of charge at rest, right, or simply static charge. Right, what are all the things happen when charge in rest? That is dealt in electrostatics. For example, when charge is at rest, it will create field, it will create force, and potential will also be created. So all those studies are collectively known as electrostatics. So study of static charge and related phenomena. What are the related phenomena with the static charge? Force, field and potential. This is known as electrostatics. Right? So electrostatics is governed by two important laws. One is Coulomb's law. Second one is Gauss law. In this video we see Coulomb's law. Gauss law we will deal later. Okay. So Coulomb's law. Coulomb's law, I write clearly CU. Right. So Coulomb's law is dealing with the static charge I told. So what is the significance of Coulomb's law is it quantifies force between two charges. Right. So quantifies force between two charges. What is the meaning of quantifying force between two charges? See, let us assume that two persons are there, A and B, right? Suppose A slaps B in the cheek. B will cry depending upon the force A applied, right? So, but how much pain he is feeling, we don't know. If B says he is feeling more, we will accept. If B says he is feeling less, we will accept. But if we are having some quantity to measure that, if that quantity is high, we can say B felt so much pain. Or if quantity is less, we can say B felt very less pain, like that. So I want some quantification of the force, right? So that quantification of the force between the two charges is given by Coulomb's law, right? So let us assume that two charges Q1 and Q2 separated by a distance are located in free space, right? As usual, both the charges must be static. They should not move, stationary, right? So free space is nothing but our vacuum only, right? So don't confuse that. The general term is free space, right? So when two charges separated by a distance r is located in the free space, the force between the two charges is given by Coulomb's law. That force, as per Coulomb's law, the force is directly proportional to the magnitude of charge Q1, magnitude of charge Q2, and inversely proportional to the square of the distance between the two charges. This is what Coulomb's law. So the proportionality constant is K into Q1, Q2 by R square. Right, so K is a Coulomb's constant. The K value is given by K is equal to 1 by 4 pi epsilon naught. The expression for K is 1 by 4 pi epsilon naught, and the value of K is 9 into 10 power 9. where epsilon naught is permittivity in free space. That value is 8.854 into 10 power minus 12. So if you substitute epsilon naught is equal to 8.85 into 10 power minus 12, you will get K as 9 into 10 power 9. These two values you should memorize. In the exam, for problem, you have to substitute the value. They won't give in the question. Okay, so this is what Coulomb's law. Right, now you see F is equal to this one. Right, I want to find what is the unit of all the parameters in Coulomb's law, right? So we know that the unit of force is Newton, that we know, right? K unit, I don't know, let us derive that. Q1 charge in Coulomb, another charge in Coulomb. R is a distance, that is in meters, so meter square. So this implies what is the unit of K? This implies that meter square, bring left hand side, Newton meter square by Coulomb square. That is equal to Newton meter square C power minus 2. This is the unit of K. What is the unit of epsilon naught? We know that epsilon naught, K is equal to 1 by 4 pi epsilon naught. 1 by 4 pi is a constant, it has no unit. So I can derive unit of epsilon naught is 1 by K, because epsilon naught is equal to 1 by K. So for unit purpose only, right? Epsilon naught is 1 by 4 pi K, but for unit purpose I take 1 by 4 pi. So what is the unit of K? Newton meter square divided by C square. That C square I bring to the numerator. So epsilon naught as a unit of Coulomb square divided by Newton meter square. Right? So now we found the units of all the parameter in Coulomb's law. Next, what we have to do? We know we derive Coulomb's law. F is equal to K into Q1 Q2 by R squared. You see, K is a scalar quantity, just number. Q1 Q2 is a charge or charges, that's also a number, that is a scalar. R is a distance, that is also a scalar. But we know force is a vector. So we have to convert force into a vector quantity. How to convert, how to write anything in terms of vector? We know that unit vector A cap is equal to A vector divided by mod A, that is equal to A vector divided by A, magnitude of A. So this implies A vector is equal to A into A cap. So any vector can be represented in terms of its magnitude and unit vector. So similarly, force vector can be represented in terms of magnitude of force, that is given by this formula. So K into Q1 Q2 by R square, A cap unit vector. Similarly, here unit vector is R cap. Right? So this is what Coulomb's law. This is a force between the two charges in Coulomb's law. Right? So in which direction the force will act? That is the next question. Because we know the magnitude of force is given by K into Q1 Q2 by R square. R cap gives the direction. Unit vector gives the direction. But in which direction the force acts? In order to find that, you see, let us assume Q1 is here, Q2 is here. In order to find the direction of force, you have to draw a line from the center of one charge to the center of other charge. Right? The force lies along the direction, in this direction, either this direction or this direction. It may go like this. It may be pushed like this. But the force doesn't act in this direction, in this direction, in this direction. It acts only in the direction along the line which is connecting the center of the two charges. Right? So Q1 is applying force only along this line on Q2. Similarly, Q2 applies force along this line on Q1. No other, here there is no force by Q2 to Q1, right? So this is the way force acts. I hope you understand Coulomb's law very clearly. If you are having any doubt, please ask me in comment section. I will clarify all your doubts. Thank you.